Hi everyone, I hope you all are having a great day and a great week. So let's just see this problem statement that says check if subtree. So what does this mean? Let's see with the help of an example. So we have two trees given to us. One is T and the other is S. So if the given tree S is a subtree of given tree T, then we can return true. Then our function return true. We need to build a function as if subtree that should return true if S is a subtree of T. So we can see that 5 and 10 is not equal. So let's just see that 9, the left child of tree T, is equal to S root node. No, it's not. So let's just check in the right. So we see that yes, the right child of our root T is equal to the root of S. Then we will check for its left children and right children. These all are same. So yes, we can return true that S is a subtree of T. Let's see another example. If we are given a tree like these T and S, we will firstly check for 5 and 8 and 5. So 8 is not equal to 5. Then let's just see for 9 and 5. These are equal and this is equal. 10 and 5 is also not equal. So we will return false that S is not a subtree of given tree T. In this example, if we are given a tree T as null, tree as null, then what can we say? We can say that if T is null, then we will return false because if there is no tree, then there will be no subtree because subtree is a part of the tree. So if there is no tree, there will be no subtree. So we will return false. But in the case if we are provided t equal to null and s is also equal to null, then we can return true because both of the trees are same. Both are null. Okay. If the tree is same, both s and t are same, then also we can return true because the whole tree, like the tree is this. So the whole tree is also considered as a subtree, is also considered as one of the subtree. How many subtrees this tree can have? One this, another this, and all the leaf nodes are subtrees, and the main tree is also a part of the subtree set. So there are a total of 1, 2, 3, 4, 5, 6, 7 subtrees, and we can also say that if there is a null, then there is total of 8 subtrees. If S is any one of these, if S is equal to 5, 9, 10 and all of this tree equal, then we can return true. If S is equal to just 9, 11, 12, then we can also return true. If S is equal to 10, 11, 13, then we can also return true. And if S is equal to 11, 12, 11, 13, any of the root node, then we can also return true. And if S is equal to null, then we can also return true. In the any other cases, we will return false. So this is the question. Yes, let's just see the last example that if S is null, then also we can return true because all the leaf nodes have null as their children. So null is always a subtree of the given tree. So we have understood the question very clearly. Let's just see how we can solve it. How can we solve it? One can see that, okay, that I have given a tree T as, let's just say 5, 9, 10, 11 and 12. And 10 has no children, so there will be null as its children. Let's represent null as n. Similarly, for the leaf nodes, left and right children are always null. And S is a 10 and null. Okay. So how can we check that S is a subtree of T or not? First we can see that S is null or not. If S is null, then we can clearly return true. If S is null, then we can clearly return true because null is always a subtree of any tree. So we can clearly return true. But if this is not the case, then we can check for T. If T is a null, right? If T is null. So first we can see that S is not null if we are executing this statement. That means this statement says that S is not null. That's why we haven't returned true. we come to the second statement and see, okay, S is not null. Let's just see that T is null. If it is null, then we will return false, because if there is no tree, then there will be no subtree, right? So these are the base cases. If this is not the case, then there must be two trees given to us, in which we have to check for the subtrees. So what will we do? We will make a function for checking that. Let's just name that function as check, and that function will return a boolean value. We will provide some node to it, and in this function we will see that if t is equal to null and s is also equal to null, means we have reached till the leaf node, both are null, then return true. But if this statement doesn't return any value, means that t is either both of them have some value, or maybe any one of them has null. So let's just check for t is equal to null or s is equal to null. So this is a or case, right? Or s is equal to null. So if only one of them is null, then we will return false. And okay, now we have seen the null part and the not null part. Now the main thing is value. We have to see the value, that this data is equal to this data or not. 5 is equal to 10, no. So t dot data, or we can say t arrow data in C++, is equal, if it's not equal to s dot data, then we will return false if it's not equal. And if all the statements are executed and there is nothing to return because there is some value, this condition doesn't get fulfilled, neither this nor this, which means we will return true, right? But we have checked for one node only. We have checked for this node, and if this is not the case, if this returns false, then whole thing will return false. No, we have to check in the left part too. We have to, sorry, we have to check in the left part also. We have to check in the right part also. So first we will check in the right part, then we will check in the left part. So we will call for the left part t dot left and s dot left. Then we will call for the right part t dot right and s dot right. And how we will call this check function in our main function? First we will call it for the root nodes. We will call it for t and s. Then we will call it for right node of t and s, and then left node of t and s. So let's just see the code. It's pretty simple. It's in Java. I will also show in C++ and Python. So the code is like, we are building a is subtree function. So we will check if the provided s is equal to null, then return true, because every null tree is a subtree of any given tree. But if the given tree is null, then return false. And then check for the root nodes t and s. If they both are null, return true. If only one of them is null, then return false. If both of them has some data, then check that data is equal or not. If it is equal, then check for the left part too and the right part also. Okay, after checking this, if this returns false, it can be the case that this return false, then we will check for the t dot left and s and t dot right and s, and we will run this same function. This function is working. I have submitted it. It is working. So let's just see the C++ solution. Okay, 305 cases are there and all are clear. Let's just see the C++ solution. In C++, what we have did, we have checked for t is equal to null and s is equal to null. If both the trees given are null, then return true. If both the trees given and only one of them is null, then return false. Okay. So this is the same thing written here. Same thing. Then we will check for the data part. Right. Okay. So I will call for the is same function. Is same. If the roots are same, then return true. If they are not, then check for the t left and s. We will check that subtree s is present in the left part of tree or not. If it is not, then we will check for the s that it is present in the sub part of right of the given tree t or not. For checking that, we will use the same conditions. If both of them are null, then return true. If either one of them is null and other is not null, then return false. If their data is not equal, then return false. And if everything is going well, then check for the left of both and right of both. Okay. So this is also working. Let's just see the Python code. In Python code, the code is very short. First, we see that s is null, then return true. If t is null, then return false. Then we will call the function same tree. If the root node t and the root node s are equal, if they form equal, if this function return true, then return true. Otherwise, check in the left part of t. If left part of t have a subtree as s, then return true. If the left part don't have that, then check in the right part of t that there is some s as a subtree or not. Then return true if it's there. For checking this, we have built a function. In this function, we are first seeing that both the trees, both the root values are null, then return true. If both the root values are not null and their data is equal, then return true. Otherwise, check for the left part and right part. Then return false if this statement doesn't return true. So this is also working. Thank you so much for watching. Now I will see you in the next one.